Hi everyone, welcome back to my channel. Let's start today's session. Now let's start the chapter circles. Circles typically carries a weightage of 7 to 8 marks out of the total 80. That means almost a 10% we will get from this chapter for our board exams. So if we know the theorems from the 9th grade, then it will be very easy to score this 7 or 8 marks which comes from chapter. Okay, so in this figure you can see that here three circles are given. This is the first one. In the first circle, you can see that there is a line PQ drawn along with that one. Now you can see that there is a gap between the line and the circle. So we can tell what, with respect to the circle, the line is non-intersecting. Means what? They are not touching each other. And then comes the next figure where you can see a line PQ which passes through the circle and it touches on the surface of the circles at the points A and B. Here we can call this AB as what? From here till here we can call this one as what? A chord. What will a chord do? Chord will divide the circle into two parts. The major part will be called as the major segment and the smaller part, that is the minor part, it will be known as the minor segment. Okay. Then if this chord is equal to the diameter, means if the line is passing through the center means what? Then the chord is equal to diameter. Chord means then that will be the diameter of the circle. In that case, what it will do? It will divide the circle into two equal halves. Then comes the third circle. Here you can see that the line PQ, it passes through the circle only at it touches the circle only on a single point, that is the A. This line we will call, the line PQ is called the tangent. Clear? So what's a tangent? Tangent to a circle is a line that intersects a circle at only one point. Here you can see that it touches only at the point A. Right? This is called a tangent. Clear? Now we have to learn one theorem. In this chapter we have to learn only one theorem. That theorem is also important. Now let's do the theorem 10.2. Here the theorem says that the length of a tangent drawn from an external point to a circle are equal. Here the P is what? P is our external point. And PA and PB are the tangents. As per the theorem, what we have to prove? We have to prove that PA equal to PB. In order to do that, what we have to do? We have to join OA, OB and OP. Okay. So what all things are given? A circle with the external point P, PA and PB are the tangents to the circle. Here what we have to prove? We have to prove that PA equal to PB. Then what do you have to write? We have to do one more construction here. That is, what we have to do? Join OA, OB, OP. After joining, what we will get? Here we are getting a quadrilateral OAPB. Okay, once after this construction, we are getting a quadrilateral. So let's write it here. Now we get what? Now we get the quadrilateral OAPB. Here in triangle OAP and triangle OBP, that is which two triangle? This one is our OAP, right? And this one is our the second triangle OPB. These two triangles we are getting here. In these two triangles, you can see that OA equal to OB. Why? These both are the radius of the circle. OA and OB are radius of the circle. Therefore, we can, that is radius of circle. Then we can write what? OP equal to OP because it is common to both, common side. Then I can write this angle will be equal to 90 degree. Why? We have learned a theorem in 9th grade that tangents at any point of a circle is perpendicular to the radius through the point of contact. So, this is the AP. If AP is a tangent, then what? OA is the radius. The meeting point of this tangent as well as this, when we are drawing a radius to the tangent, what we will get, the angle that we will get there is a 90 degree. Okay, so you can use the theorem here. That is, O angle A equal to angle B, because tangent at any point of a circle is perpendicular to the radius through the point of contact. So now we got the 3 points. So we can write what? Therefore, triangle OAP is congruent to triangle OBP. By which criteria? By RHS, right? By RHS congruence condition. Okay, then we can write what? Therefore, if these two triangles are congruent, then we can write what? AP equal to PB, right? By what? By CP/CT. Therefore, PA equal to PB, that is by CP/CT. Hence, proved. This is what they're asking us to prove, right? So we proved that one. What we proved? That length of the tangent drawn from a common external point to the circle are equal. Clear? Now let's do the exercise 10.2, question number 3. If tangents PA and PB from a point P to a circle with center O are inclined to each other at an angle 80 degree, then angle POA is equal to. This is the question here. So here it says what? This PA and PB from the point P, these are what? These are the tangents, right? These are the tangents. And they are telling that these tangents are inclined to each other at an angle of 80 degree, means they are at, here the angle which forms here is the 80 degree. And they are asking us to find angle POA. That means you will have to connect this one to here. When we will connect like this, we will get this angle, right? That angle they are asking us to find. Okay, so in order to do that one, what we will do now, we will connect this line also. Here, now you can see that here we are getting a quadrilateral, right? Which quadrilateral? Quadrilateral PAOB forms a quadrilateral, right? So in the quadrilateral PABO, you can see that here what is the angle at this angle? Angle A and angle B will be 90 degree. Why? There we will be using the theorem. Tangents at any point of a circle is perpendicular to the radius through the point of contact, right? This is a tangent. This is a line from center of the circle and it touches where the point of contact of this tangent, right? So then what it will do? It will make an angle 90 degree here. Similarly, by using the same theorem, angle B is also equal to 90 degree. Now first we will write in quadrilateral PAOB, we can tell that angle OAP plus angle APB plus angle PBO plus angle BOA, which is equal to what? 360 degree. We know that as per the angle sum property of a quadrilateral, the total angles sum of a quadrilateral will be equal to 360 degree, right? Therefore, now we can see that what is angle OAP? This angle equal to 90 degree, right? This is equal to 90 plus next angle APB equal to how much? 80 degree plus angle PBO. This is also equal to what? 90 degree plus angle BOA. What is angle BOA? It is unknown. So we will keep the BOA like this itself, which is equal to what? 360 degree. So here on adding these all things, what we will get? We will get 90 plus 80 plus 90. It is equal to 260 degree plus angle BOA equal to how much? It is equal to 360, right? So we can write that. Therefore, what is angle BOA? Angle BOA equal to 360 degree minus 260, which is equal to how much? This is equal to 100 degree. That means this angle equal to how much? This total angle is equal to 100 degree, right? Now, you can take that total angle, we got it as like the 100. Now we can take what? We can take the triangle here. From here, let us take the triangle PAO and the triangle, this triangle as well as this triangle. Okay. In both these triangles, we have to find whether it satisfies any congruency. Okay. For that, in triangle PAO and in triangle PBO, what all things are there? Look here, in triangle PAO and in PBO, these are what? This is the radius of the circle. Similarly, this is also the radius of the circle. So what I can write here, OA equal to what? OB. Why? It is the radius of the circle, right? Next thing what I can do, I can write OP equal to OP. Why? It is a common side, right? Then as per the theorem, we can again write that AP equal to what? PB, right? Why? Tangents drawn from an external point to a circle are equal. This is what we have learned in today's theorem, right? So, from there we can write these all things now. Now, OA equal to OB, OP equal to what? OP. Why? It is common. OA equal to OB. Why? It is the radius. And next we can write AP equal to what? PB. For that you can write the reason as what? It is a theorem, okay? Tangents drawn from an external point to a circle, what it will do? Are equal. Clear? So we got that one. Now we can write, therefore triangle APO is congruent to triangle what? BPO. By which congruency condition? By SSS. Okay. Now from here, if these two triangles are congruent, triangle APO is congruent to triangle BPO, then what I can write? Then I can write that angle POA equal to what? Angle POA equal to which angle? That means this angle will be equal to this angle, right? By CPCT. So I will write it here. Angle POA equal to angle POB by CPCT, right? Then what we will do? Then angle POA plus angle POB equal to how much? Angle BOA, right? This total angle 100, this is our total angle, right? Angle BOA, which is equal to 100 degree. That is what? It is a combination of this angle plus this angle, right? Angle POB plus angle POA. So we can write it here. That's what I wrote it here. That is angle BOA equal to angle POA plus angle POB. So again we have learned what that is equal to. Then I can write 2 angle POA equal to what? Angle BOA, right? Why? Because here already we have proved that angle POA equal to angle POB. So I replace one POB using POA. Thus I can write what? 2 angle POA equal to angle BOA. Therefore what? That means angle POA equal to what? POA equal to angle BOA divided by 2, right? What is angle BOA here? Which is equal to 100 degree divided by 2, which is equal to 50 degree. Thus we got angle, therefore angle POA equal to how much? It is equal to 50 degree. Our question was to find out what? Angle POA, which we got it like 50 degree, which is option number 1A. Okay. Clear, right? Now let's do the question number 7. Two concentric circles are of the radii 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. Okay, so here they are telling that we have to draw a chord for the larger circle in such a way that that chord should touch the smaller circle too. That means here if I am drawing a chord like this, look, that chord touches the point here, right? This point P. Okay, so let me mark that point as P and this, let the name of this chord be AB. Okay, and they are telling to then they are telling what the radius of this larger circle is 5 cm and radius of the smaller circle is 3 cm. Here what we have to find? To find what? To find AB, right? Now, what all things are given? They are telling that two circles are there. Both the circle are concentric. That means that they share the same center. Okay. And the larger circle is 5 cm and the smaller circle is 3 cm in radii. From here till O, I will connect a point. And from there, what I will do, I will connect from here till P. Then I will connect from O to P. I will connect now. So what all things are given? You know that OA is the radii of what? Larger circle. So I can write it that one as what? 5 centimeter. Right? Then if you are observing till here, this part till here, this much is what? That is the radii of the smaller circle, which is equal to 3 centimeter. Okay. Now what we can write? OP is perpendicular to AB. Why? Why I can write OP is perpendicular to AB? Because here AB forms a tangent to the smaller circle, right? And the tangent at any point of a circle is perpendicular to the radius through the point of contact. Look, this is the radius that I have drawn OP, a line from where? From the center to the point of contact of the tangent, right? AB. So AB is the tangent and P is the point at which it connects the circle. So that is the point of contact of this tangent, and we are connecting O to P. Then what should happen? As per the theorem, the angle which forms here should be equal to how much? This angle should be equal to 90 degree. Right? Therefore, we got that is OP is perpendicular to AB. Then what we can do? In triangle OAP, if I am taking the triangle OAP, which is equal to this triangle, so what does it say here? That is equal to, by applying the Pythagoras theorem, what I can write? OA is what? Our hypotenuse, right? OA square equal to AP square plus OP square, right? Using the Pythagoras theorem. What is the OA square here? 5 square equal to AP square is, we don't know the value for the AP square. I will keep the AP square the same. But we know the value for OP. Why? OP, if I am taking this value also, OP is what? It is the radius of the circle. What is the radius of the smaller circle? Radius of the smaller circle is 3 centimeter. So that is 3 square, which is equal to 5 square minus 3 square equal to AP square. What is 5 square? 25. 25 minus 3 square is 9. 25 minus 9 is 16. That is 16 is equal to AP square. Therefore, AP equal to how much? AP equal to root of 16, which is equal to 4 centimeter. So, I got my AP equal to how much? AP, I got it like 4 centimeter. If AP is 4 centimeter means what is AB? AB equal to, therefore, actually when we will draw a line from the center to the a perpendicular line from center to the tangent, what will happen to a chord? Here AB is the chord of the larger circle and OP is the line drawn from the center. So when this OP touches the AB, what will happen? We have learned in the 9th grade a theorem. Then that point P will be the midpoint of the chord AB. That means if I am having a circle like this and I am having a chord like this, if I am drawing, this is my center. Okay, from the center when I am drawing a line perpendicular to this chord, what will happen? It will bisect the chord into 2 equal half. That means here this will be of equal measurement. If this is A and B and this is a point P, means AP should be equal to PB. This is a theorem that which we have learned in our 9th grade. So as per the theorem, we can write what? If AP equal to 4 centimeter, therefore PB is also equal to 4 centimeter, right? That means our AB equal to what? 2 times AP, which is equal to 2 into 4, which is equal to 8 centimeter, right? Thus we got the length of the chord, right? So the length of the chord of the larger circle is 8 centimeter. So the length of the chord of the larger circle is 8 centimeter. Clear? Now let's do the question number 8. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD equal to AD plus BC. So what do you mean by the circumscribe? Circumscribe means to restrict something within a border. That means what? Here the circle, it is inside the quadrilateral ABCD in a such a way that it touches on each side of the quadrilateral, right? That is a word meaning for the circumscribe. So here you can see that what we have to prove first, to prove what? To prove AB plus CD equal to AB plus CD equal to AD plus BC. Whenever we are getting a question, what we have to do, we have to first write the given things, then we have to write to prove. If there any construction is there, means that we have to write as a third step, then we have to go into the proof. Then only we will get the full mark. Here in this question, what all things are given? Given things are that the quadrilateral, there is a quadrilateral ABCD, it has drawn circumscribe a circle. Here then we have those items, you will have to write it here. Then you will have to write to prove. What is to prove here? That is AB plus CD equal to AD plus BC. Then we will have to write our proof. What is our proof here? Proof says that here D is what? If I am considering this point D. D is an external point, right? D is an external point and it is a DR, this one and this one. DR and DS are the tangents from D, right? Therefore, I can write what? DR equal to DS. Why? Using our theorem. Because length of the tangents to a circle from the external point are equal. That theorem you will have to write it here. DR equal to DS. Okay, and that equation I'm naming it equation number 1. Similarly, if I'm considering D as my external point and RC and CQ as my tangent, I can again write there CR equal to CQ. Similarly, at the point B also I can use the same method. That means BP equal to BQ. Similarly, A. What? AS equal to AP. In that way, I will get 4 equations. Let me write all those 4 equations now. That is, you can write just similarly and copy down the equations. That is BP equal to BQ. Then what? AP equal to AS and CR equal to CQ. For this, I will name it as equation 2, 3 and equation number 4. Then what I have to do? I have to add equation 1 plus 2 plus 3 plus equation number 4. So that is DR plus BP plus AP plus CR. It is equal to, this is my left hand side, right? And what is my right hand side? That is DS plus BQ plus AS plus CQ. That is DS plus BQ plus AS plus CQ. Okay, now what I can do is that this one and this one, look, DR and CR, when added together, what I will get? I can now pair up them both. And this one, I will write it together. DR plus CR plus BP plus AP equal to DS plus AS plus BQ plus CQ. Okay. What is DR plus CR? Look the figure. DR plus CR is CD, right? What is BP plus AP? BP plus AP is AB. Equal to, what is DS plus AS? DS plus AS is AD plus, what is BQ plus CQ? BQ plus CQ. That means this side. That is equal to BC. Right? So we got what? That is equal to CD plus AB equal to AD plus BC. I can again rewrite this one and just write it like what? AB plus CD equal to AD plus BC. Hence proved, right? This is what they are asking us to prove here. AB plus CD equal to AD plus BC. Hence proved. At the end, just write it here. Hence proved. Now let's do the question number 9. In figure 10.13, xy and x dash y are two parallel tangents to a circle with center O and another tangent AB with a point of contact C intersecting xy at A and x dash y dash at B. Prove that angle AOB equal to 90 degree. Here we have to show that this angle equal to how much? This equal to 90 degree. That is what we have to prove it here. Then what all things are given? They have given that this line xy is parallel to what? The line x dash y dash. Okay, so what all things I can get it from this figure? Here we can consider this A as an external point And AP and AC are the two tangents here. So we can tell what AP equal to AC by using the theorem. If A is an external point and the tangents drawn from the same external point to the same circle, what we will get, the length of that tangents will be equal. Then another one more point that we will get it here is that this angle will be equal to this angle. That is, both angles will be equal to 90 degree. Why? Because here we can see that the P and Q are the point of contact of these tangents, right? So when I'm drawing a radius from O to P, what will it do? It will connect it that point at 90 degree. That is, OP will be perpendicular to the tangent XY, as well as here if you are looking in this part means this OQ will be perpendicular toward this tangent X dash Y dash. Clear? Like that, these all things we will get it from this figure. Then one more thing that we have to do is that, okay, we have to join OC. That means from here till here you have to join this line. Okay, then from here we can do the rest of the parts. So now let's first start from our given. Whenever we are getting a question, the first thing that we have to do is that we have to write the given part. Then we have to prove. What we have to write is that if anything construction is there means that we have to do. Then to prove. Then what we have to do? Proof. Given xy is parallel to x dash y dash. Then what is to prove what? To prove angle AOB equal to what? AOB equal to 90 degree. Now we need to do our proof. How to write our proof? So first of all here we have to consider these two triangles. The triangle PAO and next we have to consider the triangle AOC. In these two triangles we have to consider these two triangles and we have to check whether these two triangles are congruent or not. Then if they are congruent, if we are able to prove that they are congruent, then we can write what this angle is equal to this angle. That is, angle 1 is equal to angle 2. Till that we can do first. Then in the next step what we can do, similarly we can consider these two triangles here, this triangle as well as this triangle. Here also if we are able to prove that they both are congruent, then what we can write, then this angle will be equal to this angle. That means if this is angle 3 and this is angle 4 means angle 3 will be equal to angle 4. This much first of all we have to do it here. So let us go to that steps. So in proof, what we will do first, in triangle OPA and triangle OCA, angle OPA equal to what? Angle OCA equal to 90 degree. Why? Angles form at the point of contact of the tangents with the radius is 90 degree. Then we have to write the theorem in the bracket. Because why? Angles form at the point of the contact of tangents with the radius is 90 degree. What is that? OP equal to OC. Why? OP and OC are the radius here, right? They both are the radius, right? This is also our radius. This is also radius. This is also radius. This is also radius, right? So OP and OC are radius. Then I can write AO equal to what? AO, which is a common, right? Common to both. So I can write it is common. Then therefore we can write what? So triangle OPA is congruent to triangle OCA by which congruency criteria? By RHS. Okay. Now if we are able to prove that these two triangles are congruent, similarly what we can do, the same thing I can apply on the next part. That is from here till here I can do the same thing here. That is in the triangle. I can prove that triangle OCB is congruent to triangle BOQ. Okay, so no need to repeat the steps again because we have to follow the same steps. So we can write similarly and we can write that part. Therefore, similarly, what I can write, triangle OCB is congruent to triangle OQB. Right? Then if these two triangles are congruent, what I can write? Then this is also by the same RHS congruency criteria. Okay. So here, one more thing. From here, this part, right? Triangle OPA is congruent to triangle OCA. It means that from there I can write POA is equal to angle COA and that I will mark it like the equation number 1. Why? Why I can write like this one? Because by CPCT, right? By CPCT, I can write that angle POA equal to angle COA. That is angle 1 equal to angle 2. Okay. Then similarly from the triangle OCB congruent to triangle OQB. That is also by which criteria? By RHS. Here also I can write one more equation. That is angle QOB is equal to angle COB. That is 3 equal to angle 3 equal to what? Angle 4. And for that one I can write this equation number 2. This is also by what? By CP/CT. PQ is what? PQ is a straight line. If PQ is a straight line means what? Then the angles POA plus angle AOC plus angle COB plus angle BOQ is going to be 180 degree. So let me write that part. That is PQ is a straight line. PQ is a straight line. Therefore, what all things I can write? Angle POA plus angle COA plus angle COB plus angle QOB equal to 180 degree. That is, here from the equation number 1, if you're checking the equation number 1, and I can replace this POA by what? I can replace the POA by angle COA because both are equal. That is angle COA plus angle COA plus from the equation number 2, I can replace this QOB by which one? Instead of this QOB, I can write angle COB. That is angle COB plus in place of the QOB, I will replace it by COB, which is equal to 180 degree. Therefore, if you are observing here, you will get 2 angles of COA, right? That is 2 angle COA plus 2 angle COB equal to how much? 180 degree. That is 2 into angle COA plus angle COB equal to how much? 180 degree. That is angle COA plus angle COB equal to 90 degree, right? COA plus angle COB equal to angle AOB. That is angle AOB equal to what? AOB equal to 90 degree. This is what they are asking us to prove. Therefore, we can write what? Hence proved. Now let's do the question number 12. A triangle ABC is drawn to circumscribe a circle of radius 4 cm such that the segments BD and DC into which BC is divided by the point of contact D are of the length 8 cm and 6 cm respectively. Find the sides AB and AC. Here they are asking us to find what? AB and AC we need to find. In order to find these things, what all values are given? CD is given as 6 cm, BD is given as 8 cm, and they are telling the radius of the circle is equal to 4 cm. So let me first write the given items here. What is given? Given OD equal to how much? OD equal to 4 cm, which is a radius, right? It is a radius. Then I can write what? CD equal to how much? It is 6 cm. It is given. Then it is given DB, which is again equal to 8 cm. Now I can write what? Here what? Now I need to do some constructions here. Okay. Then I have to do the constructions here. What are the constructions that I'm going to do here is, first one, I will find the point of contact of the tangent AC and the circle. That is this point, and I will mark that point as point F. Okay, and here also I will find out my point of contact of the circle and the tangent AB, and that one I will mark it as a point E. Now what I will do, I will connect this OF and I will connect this OE. Okay, this OF and OE. Thus I will connect this one. Okay, now again what I will do is that from this OE, I will connect that till the OC. From here, that what I will do, I will connect till the OB. Now I am getting these many figures inside this one, right? So what I have to do, I have to connect OF, OE, OC and OB. Okay, now what we have to prove? To prove what? To prove, we have to find AB and AC. Find AB and AC, right? Now from here it starts our proof. This question is really important because if I'm checking from the 2012 even, this question get repeated in every 2 years. Okay, so this is really important. Don't miss this question. Now we have to do the proof. For that one, what I have to do, they are telling that this value is equal to how much? It is equal to 4 centimeter, which is the radius of the circle. Similarly, this OF and OE is also the radius of the circle, right? So that value of OF is also equal to OE, which is again equal to 4 centimeter. Then one more thing, if I'm seeing here, the C, if I'm taking as an external point, then CF should be equal to CD. Because of the theorem, right? Using the theorem, we can write that tangent from an external point is equal in length. That means if this is 6 centimeter, means this value C is also equal to how much? 6 centimeter. Similarly, if BD is 8 centimeter, means this BE is also equal to 8 centimeter. Why? If I am considering B as an external point, then as per the theorem, BD is equal to BE. Okay, these all things let me write in our proof. First, what we had to write? CF equal to CD equal to 6 centimeter. Then BD equal to BE equal to how much? 8 centimeter. Why? This is because tangent from an external point is equal in length. Then what I'm going to do the next is, I'm going to give this value AF equal to, let this value AF equal to X centimeter. If AF equal to X centimeter, automatically AE will also become X centimeter. Why? Similarly, A is an external point here. And AF and AE are the tangents drawn from A. Therefore, the X will be what? If X is AF equal to X centimeter, means automatically AE will be also equal to X centimeter using the theorem. Okay, then I have to write, let AF equal to AE equal to X centimeter. Therefore, AB equal to what? Check there. What is AB? AB means from here till here. What is the total sum of AB? X plus 8 centimeter. AB equal to X plus 8 centimeter. Similarly, what is AC here? AC equal to what? AC equal to X plus 6 centimeter, right? Look, this. X plus 6 centimeter. Now, what is BC? BC equal to here. BC equal to DC plus DB, which is equal to 6 plus 8 centimeter. 6 plus 8, which is equal to 14 centimeter. Now we got AB, AC, BC. Now what we are going to do is that we need to find the area of the triangle ABC. If I want to find the area of the triangle ABC, since the length of the sides are given, which equation we can use in 9th grade, we have learned about the Heron's formula. Using that one, from there we will do what? First we have to find the perimeter of the triangle ABC. What is the perimeter of the triangle ABC? Perimeter of triangle ABC means we have to add up all the sides length, which is equal to AB plus BC plus AC, which is equal to, what is AB here? AB is given as X plus 8, then BC is given as X plus 6, AC is given as 14. So, what I will get here, which is equal to X plus 8 plus X plus 6 plus 14. X plus X is 2X. 2X plus 8 plus 6 plus 14 is equal to 28. So, I got perimeter P equal to 2X plus 28. Now, from here I can find the semi-perimeter, right? Because in our equation we are using semi-perimeter S. Semi-perimeter of triangle ABC equal to what? Equal to perimeter of triangle ABC divided by 2. Half of perimeter is semi-perimeter. So, which is equal to what? 2x plus 28 divided by 2 means from here I can take 2 outside, which is x plus 28 divided by 2 means how much I will get? I will get 14 divided by 2. This and this will get cancelled. So, I will get semi-perimeter S equal to how much? X plus 14. Area of triangle ABC using semi-perimeter means which equation we need to use it there? Our equation should be S into S minus AB into S minus BC into S minus AC. right? We have learned our equation is what for finding the area of the triangle using that one as root of s into s minus a into s minus b into s minus c. This is the equation that we have learned, where a denotes the one side of the triangle, b denotes the second side of the triangle, and c denotes the third side of the triangle. Okay, side length. Therefore, now we got that. Now, if I want to solve this equation, what I need? Now, next part that I need is s minus ab. Similarly, I need s minus bc, s minus ac. If I am substituting all those values into this equation only, I can solve this equation. For that, what I will do? Now, I will start finding the values for s minus ab. What is s minus ab? S minus ab equal to s equal to how much? X plus 14 or 14 plus x. In any way you can write. So 14 plus x minus, what is ab? Here we have found ab, right? ab equal to x plus 8. So minus, here I will write 8 plus x. So here I can write it like that, what? 14 plus x minus 8 minus x. This one and this one will get cancelled, and I will get 14 minus 8 equal to how much? 6. So I got my s minus ab equal to how much? S minus ab equal to 6. Now I need to find s minus bc, which is equal to 14 plus x minus how much? bc is 14, which is equal to 14 plus x minus 14. Here this 14 and this 14 will get cancelled, and I will get x. Now I need to find what? I need to find s minus ac, right? What is s minus ac? S equal to 14 plus x minus, what is ac? ac equal to 6 plus x, which is equal to 14 plus x minus 6 minus x. Here this one and this one will get cancelled. 14 minus 6 is equal to how much? It is equal to 8. Now, I got my equations for s minus ab, s minus bc and s minus ac. For this one, let me give this equation number 2. And this one, let me give the equation number 3. And this one as equation number 4 means I need to multiply 2, 3, 4 in order to get s minus a into s minus bc into s minus ac. Right? So, what is s minus ab into s minus bc into s minus ac means? Which is equal to s minus ab is how much? Equal to 6 into x into 8. How much I will get? It is equal to 48x. Now I got this value. Now what I need to do? I need to substitute these values into our equation. This equation, right? That is area of triangle ABC. Therefore, area of triangle ABC equal to root of s into s minus AB into s minus BC into s minus AC. What is s? We already proved that. Now find the value for the s, which is equal to root of 14 plus x into 48x. Okay, so now we got this value. This one I will give like the equation number 5. This much centimeter square is the area of the triangle ABC. Now I can find, so here x is there, x is an unknown. So using this, now I need to find the x, then only I can find these values, right? For that one, I will do another one process, that is, now what I will do, take my triangle here. Here I will take the triangle. Here you can see this triangle, right? This triangle, I will first consider this triangle because I can find the area of this triangle using our like half into base into altitude. Using that equation, I can find the area of this triangle. Which triangle? Triangle OCB. So, what is my base here? Base is equal to BC and my altitude is OD. So, using this one, these values, I can find the area of the triangle OBC. Let me write it here. Therefore, now let me find area of triangle OCB, which is equal to half into what? Base is what? Base into altitude, right? Base into height or base into altitude. That means which is equal to what? Half into base is BC into OD, which is equal to half into what? 14 into 14, which is equal to 28 centimeter square. Connect this OCA. Okay. Now, in order to find the area of the triangle OCA, similarly, I can use the same equation. Here, I can consider AC as my base and this OF as my altitude. Using that equation, I can find the area of the triangle what? AOC. Area of triangle OCA equal to how much? Half into CA into OE, right? Which is equal to half into x. What is AC here? AC equal to x plus 6 into OE equal to 4, right? Which is equal to half into this one, and this I can cancel, and what will happen? So here it will become 2 into x plus 6, which is equal to 2x plus 12, right? That means centimeter square is the value for area of the triangle OCA. Now let's find the area of the triangle OAB. Area of triangle OAB. What is the area of the triangle OAB? Look here, look in the figure. This empty figure, that is OAB, is equal to what? Here I can take AB as my base, this as my base, and this as my altitude, right? That is half into AB into OE is the equation for that one. Let me write that it here. That equal to half into AB into OF, which is equal to half into, what is AB? AB equal to x plus 8, and OF equal to how much? It is equal to 4, right? So which is again equal to what? Here I can cancel this 2, and what I will get here, I will get 2 into x plus 8, which is equal to 2x plus 16. 16 centimeter square is the value for area of the triangle OAB. Now what we can do? Now we got all these triangles separately, right? The triangle OAC, area of the triangle OAC is there, area of the triangle OB is there, then area of the triangle AOB also we found. Now when we will add these three triangles together, then we will get the area of the triangle. Area of the triangle ABC equal to area of triangle OBC plus area of triangle OCA plus area of the triangle OAB. When we will add them together, we will get that value, which is equal to 28 centimeter square plus 2x plus 12 centimeter square plus 2x plus 16 centimeter square, right? This much we will have to add all together, which is equal to 28 plus 2x plus 12 plus 2x plus 16, this much centimeter square, which is equal to 56 plus 4x centimeter square, right? Now we got, for this one I'm naming it like equation number 6. Okay, now we got now what we got two values for the areas of the triangle ABC, right? Therefore that the previous equation I have given area of the triangle ABC is equal to root of 14 plus x into 48x. Here I got another equation for area of the triangle, which is equal to 56 plus 4x. From equation number 5 and 6, what I can write? Area of triangle ABC equal to, let me write that equations again, root of 14 plus x into 48x is one equation, and next equation is what? Area of triangle. Similarly, area of triangle ABC equal to what? 56 plus 4x. This my centimeter square is the second equation, right? So I can write, therefore what? I can equate them both, right? On equating them both, I can write it like root of 14 plus x into 48x, which is equal to 56 plus 4x, right? That is, in order to, now I need to remove the square. So what I will do, I will square the both equations. Before that, let me take 48x. From here, 48, I can write it like 2 2s are 4, 4 2s are 8, then again 2, 1, 2, then it is 2, then it is 6, then 2, 3. Therefore, I can write it like the, what? 48 can be written as, root of 48 can be written as how much? 4 root 3, right? Which is equal to, so this 4 I can take it outside. So 4 will go out, and I can write the remaining part as 14x plus 3 root 3x, right? So that 3 I will write inside this root itself. So 3x, which is equal to 56 plus 4x. In the next step, what I will do, I will square these terms. Okay. Now on square, here one more, 4 into root of 14 plus x into 3x equal to this 56 plus 4x can be written as how? I can take the 4 commonly outside and I can write like 14 plus x. So here this 4 and this 4 I can cancel, which is equal to 14 plus x into 3x equal to 14 plus x, right? Therefore, now I will do in the next step, I will square on both sides. On squaring both sides, what I can write, this will be, I can nullify this root now, which is equal to 14 plus x into 3x is equal to 14 plus x the whole square. Here this is of the form what? A plus b the whole square, which is equal to a square plus 2ab plus b square. So I need to substitute these values here. 14 plus x into 3x equal to what is a square here, which is equal to 14 square. 14 square plus 2 into 14 into x plus x square, right? 3x square minus x square plus 42x minus 28x, then minus 196 equal to 0. So I will get what? Here I can write it like 2x square plus 14x minus 196 equal to 0. Then here if you are observing, here you can see that we can take 2 commonly outside. When I am taking 2 commonly outside, I can write it like x square plus 14 divided by 2 is 7x minus 196 divided by 2 is 98, which is equal to 0. So this 2 on multiplying with the, means when taking to the opposite side, what will happen? I will get the equation like x square plus 7x minus 98 equal to 0. Now I need to solve this equation. Here how to solve this equation? The sum should be equal to 7 and the product should be equal to minus 98. Now I need to find the numbers which matches with this thing. So I need to find the a and b here. Here the a and b are 7 and 14. Okay, if you are looking here, you can see that minus 7 plus 14 equal to how much? Plus 7, right? 14 minus 7 is 7. Then minus 7 into 14 equal to what? Minus 98. So how can I write this 7x? 7x can be written as 14x minus 7x, right? Then I will get it as 7x, right? So in place of the 7x, I need to do what? I need to substitute 14x minus 7x, that is x square plus 14x minus 7x minus 98 equal to 0. In this way, I can rewrite the equation. So from here, what I can do, I can take commonly x outside, which is equal to x plus 14. Here I will write x plus 14 again. Now if you are checking the third term, that is minus 7x, that is minus 7x divided by the first term from here. That is x equal to how much? What I will get? Minus 7. So I need to insert the minus 7 here. That means x minus 7 into x plus 14 is the equation, right? Which is equal to 0. From first part, if x minus 7 equal to 0 means my value for x equal to 7, and if x plus 14 equal to 0 means my x equal to minus 14. So for a value, a measurement can never be equal to minus 14. So it is not required. This is not required part. So it is we can eliminate this part. So we can go with which value x equal to 7. Therefore, our x equal to how much? 7 centimeter. Now, what is AB? AB equal to 8 plus 7, right? Which is equal to 15 centimeter. Similarly, what is BC? BC equal to 8 plus 6, which is equal to 14 centimeter. If I want to find AC, means AC equal to how much? Which is equal to 6 plus 7, which is equal to 13 centimeter. Now, we got AB, BC and AC, right? What they are asking here is to find AB, and we have to find what? AB as well as AB and AC. Those two values we found, right? Thank you for watching. If you found this helpful, please subscribe and stay connected.